and page 5 of lesson 8. Okay, so a stoichiometry, whoops, I'm just going to click over here. Stoichiometry expresses the quantitative relationship between reactants and products in a chemical equation. So quantitative, remember, just means numbers. Stoichiometric coefficients in a balanced equation indicate molar ratios in that reaction. Stoichiometry allows us to predict certain values such as theoretical yield of a product. This is important because this is something you'll be calculating in your lab. Theoretical yield is the maximum amount of product that could be formed from the given amounts of reactant. In order to determine theoretical yields, you will need to perform stoichiometric calculations, and we're going to use a reaction map for this. Okay, so the next page is just to break down how to use a reaction map, and then we're going to actually practice some. So here we have our balanced equation, and you'll notice that we have our coefficients up front, and we balanced this already in a previous video. Okay, so remember we balanced this before. So basically what this is going to mean, and if you go down, we actually cross these two out just because we don't use them in this lab, so we don't care about them. I'm just going to cross them out here. If you're looking at this, if you're going to try to convert between any of these, there is a one-to-one relationship between all of them, okay? So that's what we're going to use to actually make the map. So when we look at this map, this is what we have. And you'll notice that, so we have moles, 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 okay? And these are all, this is the main road. Okay. And then we have these offshoots where we can go to grams or we can go to milliliters. Okay. And the only rule with this is whatever unit is in the numerator, so whatever unit is in the numerator goes in the denominator of the next fraction. Okay. All right, so let's go through some problems on this next page. So this is all on the next page, page 5. Okay, so here's page 5. We have this reaction map. Again, we have our main road here. You'll notice that in the main road, we are just converting from mole to mole to mole. And then we have our offshoots where we can go from moles of magnesium to grams of magnesium, or we can go from moles of hydrogen gas to milliliters of hydrogen gas, okay? You'll notice that we can only go where we have arrows. So we cannot go from moles of hydrochloric acid to milliliters of hydrogen gas. Okay, we can only get to milliliters of hydrogen gas if we start off at moles of hydrogen gas, or if we get to moles of hydrogen gas. Okay. Okay, so let's go through some sample problems. Okay, so to begin with, how many moles of hydrochloric acid are needed to completely react? So we have 0.03 moles of magnesium. So we always start by just writing the number that we're given. The number we're given is 0.03 moles of magnesium. We put that over 1. Now, without looking at anything, I know that because mole of magnesium is in the numerator, mole of magnesium is going to be in the denominator. Okay, and then I look at my map. Here's mole of magnesium. Okay, so this is where I'm going to start, and I'm trying to get to moles of hydrochloric acid, which is right next door. So I only need to go through one conversion factor to get there. So because mole of magnesium is here, I'm just going to put the 1 mole of magnesium, and then I put 2 moles of hydrochloric acid at the top. Okay, and then we multiply across, divide down. So 0.03 times 2 divided by 1 is just 0.03. To figure out my units, I cross out, so mole of magnesium cancels, and I end up with mole of hydrochloric acid. Okay. The next one is how many moles of hydrogen gas will be produced. Okay, so mole of hydrogen gas is here. I am given mole of magnesium over here. So I'm just going to start with 0.03 mole of magnesium over 1. Since mole of magnesium is in the numerator, I know that that's what's going to be in the denominator. Okay. Looking at my reaction map, so I start here, I'm trying to get over here. So looking at my reaction map, I have to go through this conversion first. So 1 mole of magnesium is equal to 2 moles of hydrochloric acid. And again, you'll notice this 1 and this 2 are just coming from here, right? Okay. So that gets me here. Now I need to go 1 more over. So since mole of hydrochloric acid is in the numerator, mole of hydrochloric acid is going to go in the denominator. And I have 2 moles of hydrochloric acid for every 1 mole of hydrogen gas. So 0.03 times 2 times 1 divided by 2. We end up getting 0.03. And then to figure out my units, mole of magnesium cancels, mole of hydrochloric acid cancels, so I'm left with mole of hydrogen gas. Okay. You could have also started with this mole of hydrochloric acid since we already had it, okay? But I just wanted to show you how to use the entire map. Okay, so this next one. How many milliliters of hydrogen gas is this equivalent to? Okay, so I have 0.03 moles of hydrogen gas, so that's what I'm going to start off with. Okay, so I'm starting here. I'm trying to get to milliliters of hydrogen gas, so I only need 1 conversion to get through that. So since mole of hydrogen gas is at the top, I'm going to put mole of hydrogen gas in my denominator. And my conversion factor says that we have 0.12345 mole of hydrogen gas for every 1 milliliter of hydrogen gas. And this should say hydrogen gas. All right, so then just get out a calculator. 0.03 times 1 divided by 0.12345. And we end up getting 1, 2, 3, 6, 7. For my unit, mole of hydrogen gas cancels out. So I end up with milliliters of hydrogen. Okay, so here are some more, and here are just the problems at the bottom. Okay, so we have 0.06 moles of hydrochloric acid, so I always start by writing down what I'm given, putting it over 1. It's asking how many moles of magnesium metal would be needed to completely react. So moles of magnesium is what I'm looking for. Moles of hydrochloric acid is here. I'm trying to get to moles of magnesium here, so I only need this 1 conversion factor in between. Okay, so mole of hydrochloric acid is in the numerator, so that means that mole of hydrochloric acid goes in the denominator. Looking at my conversion factor, I have 2 moles of hydrochloric acid for every 1 mole of magnesium. So 0.06 times 1 divided by 2 equals 0.03. To get my unit, I go back and I cancel out mole of hydrochloric acid, and I'm left with mole of magnesium. Okay, so the next question is, oh, I see. All right, so we have 0.06 moles of hydrochloric acid again. 6 mole of hydrochloric acid over 1. And I'm trying to get to grams of magnesium metal. Okay, so I'm starting here, moles of hydrochloric acid, and I'm trying to get here. That means that I'm going to have to use 2 different conversion factors to get there. Okay, so mole of hydrochloric acid is at the top, so that means that mole of hydrochloric acid goes in the numerator of the next fraction, or the denominator rather of the next fraction. If I'm looking for every 2 moles of hydrochloric acid, I have 1 mole of magnesium. Okay, now I still have this conversion factor to go. So mole of magnesium is at the top. So that means that mole of magnesium is going to be at the bottom of the next fraction. And I have 1 mole of magnesium is equal to 24.31 grams of magnesium. Okay. So the math is getting a little bit more complicated here. So what I'm going to do is I'm going to multiply everything on my numerator and then everything on my denominator, and then I'm going to divide. So 0.06 times 1 times 24.31 is equal to 1.4586. 1 times 2 times 1 is just equal to 2. So I have this number divided by 2, and I end up getting 0.7293, which I want to round to my hundredth, so I can round that to 0.73. And then I need to figure out my units. So mole of hydrochloric acid cancels, mole of magnesium cancels, so I'm left with grams of magnesium. Okay, so for this next one, we have 0.06 moles of hydrochloric acid again, over 1. How many moles of hydrogen gas will be produced? So I'm starting here, and I'm going here. I have 1 conversion factor that I'm going to use for this. Since mole of hydrochloric acid is at the top, I know that mole of hydrochloric acid goes at the bottom. So for every 2 moles of hydrochloric acid, I have 1 mole of hydrogen gas. And then 0.06 times 1 divided by 2 is 0.03. I can cancel mole of hydrochloric acid out, and I'm left with mole of hydrogen gas. Okay, so here's my next one. I still start with 0.06 mole of hydrochloric acid over 1. Mole of hydrochloric acid is at the top, so like without even looking at anything else, I know that mole of hydrochloric acid, whoops, if I can write that, mole of hydrochloric acid needs to be at the bottom of the next fraction. Okay, like without even reading the problem, I know that that's what's there. Okay, so I'm trying to get to milliliters of hydrogen gas. Okay, so I'm starting here, and I'm trying to get to milliliters of hydrogen gas. So I can count 2 different conversion factors between those. So I'm going to start with this one. So since mole of hydrochloric acid is in the denominator, that's where this number is going to go. So 2 moles of hydrochloric acid for every 1 mole of hydrogen gas. And again, since mole of hydrogen gas is at the top, I know that mole of hydrogen gas is going to go at the bottom without even looking at anything else. Okay? All right, so I still have this 1 conversion factor. So next to mole of hydrogen gas is this number. So that's what goes down here. And that's equal to 1 milliliter of hydrogen gas. And just like before, this is getting kind of complicated, so I'm going to multiply out and then I'm going to divide. So 0.06 times 1 times 1, 0.06, and 2 times 0.12, 4, 5, end up getting 0.1234,9. So 0.06 divided by 0.00009, and we end up getting 666.67. Okay, and now I just need to figure out my units. So mole of hydrochloric acid cancels, mole of hydrogen gas cancels, and I'm left with milliliters of hydrogen gas.